In a land where most soil dies after just 3 years, patches of jet black earth in the Amazon have fed humans for over 2,000 years without a drop of modern fertilizer. Archaeologists uncovered millions of engineered acres, rewriting what we thought possible for ancient farming. But if this soil technology promised infinite fertility, why did the world abandon it? The answer upends everything big agriculture wants you to believe. And what follows reveals how you could build a self-sustaining soil engine they don't want you to know exists. A shovel cuts into the forest floor, peeling back a thin blanket of leaves to expose a secret hidden for centuries. Instead of the pale, lifeless yellow that defines most Amazonian soil, a deep black layer runs like a shadow beneath the surface. This is not a trick of the light. The earth itself is different here. Archaeologists measure the depth of this horizon, sometimes half a meter thick, packed with dark, crumbly material, flecked with ancient pottery shards and bits of charcoal. In every direction, the surrounding soil remains acidic, depleted, and stubbornly red. But inside these black patches, crops flourish where nothing should grow. Lab samples tell the story in numbers. Carbon dating pushes the age of this soil back more than 2,000 years, confirming its creation long before the first European ships reached the Amazon. The chemical signature is unmistakable, with levels of phosphorus, calcium, and stable carbon far exceeding anything found in the native ground. Even after centuries of rain and tropical heat, the fertility persists undiminished. Satellite images and soil surveys revealed the scale of the phenomenon. These black earth islands are scattered across millions of acres, sometimes stretching for kilometers, always surrounded by the thin, exhausted soils that dominate the basin. Where the dark soil ends, the promise of abundance vanishes. Farmers who plant in the yellow dirt watch their fields collapse after a few seasons. But within the black earth, the same land has supported generations of harvests with no commercial fertilizer. No one alive today remembers creating this soil. Its origin is lost to time, but its power is undeniable. In a landscape where fertility is fleeting and the jungle reclaims everything, these patches stand as living proof that someone once cracked the code of endless abundance. Who built this impossible ground, and how did they do it? In 1541, as Spanish explorer Francisco de Orellana drifted down the Amazon, his chronicler Gaspar de Carvajal wrote of vast villages, fields, and a population so dense it seemed impossible for the heart of a rainforest. For centuries, these accounts were dismissed as fantasy. Later travelers found only tangled jungle and silence, not the bustling cities Orellana described. But the truth was buried beneath the canopy, written not in stone, but in the soil itself. Modern archaeologists, armed with satellite imagery and ground surveys, began to map the Amazon in a new way. Instead of searching for ruins, they traced the outlines of settlements through the patterns of black earth. These were not isolated gardens. Millions of acres of engineered soil stretched in clusters along rivers, forming a hidden map of ancient habitation. In places, the dark earth covers entire landscapes, sometimes running for kilometers, always marked by layers of pottery shards, animal bones, and the unmistakable signature of human life. Michael Heckenberger and his team, working with the Kuikuro people in the Upper Xingu, uncovered networks of villages linked by straight roads and surrounded by dark, fertile earth. Their research revealed a kind of urbanism unique to the Amazon. There were no stone monuments, but a web of plazas, causeways, and engineered soils supporting thousands. The soil itself became the monument, preserving evidence of sustained agriculture and complex society where outsiders once saw only wilderness. Each shovelful of black earth tells a story of careful management. Layers of pottery fragments and household waste trace centuries of occupation. Settlement surveys show that these patches are not random. They cluster where people lived, farmed, and built their lives. The scale is staggering. Estimates suggest that up to 10% of arable Amazon land bears the mark of this ancient engineering, confirming Orellana's reports of populous cities hidden in plain sight. What looked like a myth is now mapped in soil, demanding a new understanding of what these people achieved. The next question is not whether they built this abundance, but how they made it last for millennia. A soil scientist lifts a fragment of the black earth and crushes it gently between their fingers. Under the microscope, the secret becomes visible. A honeycomb of empty tunnels and chambers twisting in every direction. Each gram of this carbon matrix contains more interior surface area than a small apartment, somewhere between 2,000 and 5,000 square feet. These are not just cracks or random holes. They are the fossilized imprint of ancient plant cells transformed by fire and time into a permanent scaffold. This is not ash, and it is not the fluffy charcoal left over from a campfire. It is biochar, built through a process called pyrolysis, burning organic matter in very low oxygen so that the structure is preserved, but almost everything else is driven off. The result is a material unlike anything found in nature. The pores in biochar are measured in microns and nanometers, creating a labyrinth that can trap water, nutrients, and most importantly, life. Soil bacteria and fungi move into these protected spaces, shielded from drought, predators, and the constant flush of rain. The scientist explains that this porous network acts as a kind of microbial apartment complex, turning the soil into a living city. Each chamber hosts a different resident, nitrogen-fixing bacteria, phosphate-solubilizing fungi, and a cast of invisible workers that recycle nutrients and build fertility from the inside out. The structure of biochar is what sets it apart from every other soil amendment. Chemical fertilizers dissolve and wash away. Compost breaks down and disappears. But the carbon skeleton of biochar endures. Its aromatic rings and condensed carbon bonds resist decomposition for centuries, sometimes millennia. This stability is the foundation of Terra Preta's reputation for endless fertility. The scientist points out that unlike the fleeting boost from a bag of NPK, biochar creates a framework that can be recharged again and again. Nutrients stick to the surfaces inside the pores, held in place by cation exchange sites that act like magnets. Water clings to the walls, available to roots long after the surface soil has dried out. The real magic, the scientist says, is not in the chemistry alone, but in the architecture. A single handful of this material contains more habitat for microbes than an entire meadow of living grass. The scale is almost impossible to grasp. 1 gram, less than a sugar cube, offers thousands of square feet of real estate for the soil's hidden ecosystem. Over time, as organic matter cycles through, the biochar matrix becomes a living archive, storing nutrients and supporting the web of life that keeps soil productive. This invisible sponge structure is the reason Terra Preta has defied the Amazon's brutal climate for thousands of years. The ancient engineers who made it did not just add nutrients. They built a permanent infrastructure, a kind of coral reef beneath the ground. It is this physical foundation, more than any recipe or ingredient list, that explains why their soil still feeds crops long after their cities have vanished. The next step is to see how this structure translates into real-world abundance, how the data from the field confirms what the microscope reveals. A row of garden beds stretches across a small homestead, each one planted with the same crop, watered from the same hose, exposed to the same sun. But the similarities end there. In the first bed, the plants stand thin and pale, their leaves curling at the edges. This is the control. Plain local soil, nothing added. In the second, the soil has been boosted with commercial fertilizer. The plants look better, greener, taller, but not without problems. After a heavy rain, puddles form and the lower leaves yellow. In the third bed, the soil is dark and crumbly, flecked with bits of charcoal charged weeks before with compost tea. Here, the plants tower over their neighbors, their stems thick, leaves glossy, and roots pushing deep into the ground. The gardener, notebook in hand, walks the rows with a tape measure. At the end of the season, the numbers tell the story. In the control bed, each tomato plant yields a handful of fruit before the stems begin to wilt. The fertilizer bed produces more, almost double, but by late summer, the lower leaves are spotted, and the soil underneath feels hard and dry. In the biochar bed, the plants are 3 to 8 times larger than those in the control, heavy with fruit and still pushing out new growth. As the season ends, the soil stays loose and moist even after weeks without rain. A simple soil probe reveals the reason. In the control and fertilizer plots, water drains quickly, leaving the soil bone dry within days. Nutrient tests show that after a rainstorm, most of the added fertilizer has leached below the root zone, out of reach for the plants. Only about 30 to 50% of the nitrogen from the fertilizer is actually taken up by the crop. The rest is lost, washing away into the subsoil or running off into nearby ditches. In the biochar bed, the probe pulls up a clump of soil that holds its shape, damp and cool to the touch. A lab analysis shows that most of the nutrients added before planting are still present, locked in the microscopic pores of the char. The plants draw on this reserve as needed, and the soil's water content remains steady even during dry spells. In some years, the gardener waters the biochar bed half as often as the others. The numbers are consistent. The biochar plot produces 3 to 8 times more total biomass than the control and holds on to far more of its nutrients. Instead of flushing away with every rain, nitrogen and potassium stay available in the root zone, feeding the plants for months. The difference is visible above ground, but the real action is below the surface. The biochar matrix acts like a permanent sponge, soaking up water and nutrients and releasing them slowly. Chemical fertilizers deliver a quick boost, but their effect fades fast, forcing the gardener to reapply again and again. Biochar turns the soil into a living engine, one that multiplies the effect of every handful of compost or manure. By the end of the season, the biochar bed is not just more productive, it is more resilient. The plants withstand drought and heavy rain, and the soil grows richer with each passing year. The gardener closes the notebook, already planning next year's experiment, but the results are clear. Once you build this kind of soil infrastructure, you stop renting your harvest from a bag. You start owning it season after season. When the first European diseases swept through the Amazon, the world that built the Black Earth vanished almost overnight. Smallpox, measles, and influenza arrived ahead of settlers traveling along trade routes and riverbanks. Within a century, up to 90% of the indigenous population was gone. Entire villages emptied, their fields swallowed by the forest. The intricate knowledge of soil making passed down through generations was scattered and silenced, with no written record left behind. What survived was the soil itself, a silent witness to lives erased. As the centuries rolled on, the dark earth remained, but the method faded from living memory. Colonial authorities and later agricultural experts saw only jungle and ruin. When industrial agriculture took hold, the focus turned to quick fixes, bags of chemical fertilizer, annual applications, and a relentless cycle of buying and spreading. The new system was built on repeat sales. Fertility became a subscription. Each year, farmers were told to buy more nitrogen, more phosphorus, more potassium, because the nutrients would wash away with the first heavy rain. The message was clear. You don't own your soil. You rent your harvest from the bag. Meanwhile, a deep misunderstanding took root. Agricultural bulletins warned against burning crop residues, arguing that fire destroys nitrogen and leaves the soil barren. They failed to distinguish between ash, what is left after a hot fire, and char, the stable carbon scaffold that makes black earth possible. The ancient practice of controlled charring was swept up in a blanket prohibition. Extension agents and textbooks lumped all burning together, erasing the subtlety that once turned waste into wealth. The result is a system that profits from loss. Every storm that leaches fertilizer from a field is another opportunity to sell more product. The one method that could break this cycle of permanent self-renewing soil infrastructure was left behind. Not because it failed, but because it succeeded too well. The Black Earth stands as a quiet rebellion against a model that depends on scarcity. The question now is whether anyone will choose to reclaim that lost abundance. A gardener stands beside a battered metal bucket, hands stained with charcoal dust. The process begins with dry, untreated branches and sticks, never painted wood, and never pressure-treated lumber. Each piece is broken down and fed into a small fire pit built to burn hot, but not open to the wind. The key is oxygen control. Too much air and the wood turns to ash. Too little and it smolders without charring through. The goal is a deep black carbon that snaps in the hand, not a pile of gray powder. Once the flames die back and the last wisps of smoke fade, the char is quenched with water, ending the reaction and locking in the porous structure. The next step is what separates abundance from disappointment. Raw biochar, fresh from the fire, is a blank sponge, hungry for nutrients but empty. If mixed straight into the soil, it can rob plants of nitrogen. In the first season, the answer is charging. The gardener pours the cooled char into the bucket, then adds a nutrient-rich liquid, compost tea, a diluted manure slurry, or even a mix of water and fresh urine, always at a safe ratio and never straight. A 10:1 dilution is standard for urine. The bucket is stirred, then left to sit for 2 weeks. Every few days, the mixture is aerated, giving microbes a foothold inside the char's endless tunnels. After 14 days, the biochar has absorbed a living brew of nutrients and beneficial bacteria. The gardener drains off the liquid, letting the char dry until it is damp but not dripping. Now it is ready to go into the garden. A single application mixed into the top 6 inches of soil lays down a permanent scaffold. There is no need to repeat the process every year. The charged biochar becomes part of the soil itself, holding water in drought, feeding roots in lean times, and giving microbes a fortress to call home. With a few hours of work in a bucket, the gardener has built a soil engine that will keep running season after season with no subscription required. Safety comes first. Wear gloves to keep dust off the skin. Wear a mask if the char is extra fine and never burn anything toxic. The method is simple, repeatable, and proven. The hardest part is believing that something so easy can last so long. Chemical fertilizers now dominate over 90% of global cropland. Yet our soil degrades faster than at any point in recorded history. The Amazon's black earth proves that permanent fertility is possible if we choose it. Will we keep renting our harvest from synthetic cycles or rebuild what endures for millennia? The earth remembers. The question is, do we? Let me know what you think in the comments below.